Chapter 7, Section 1, Angles of Polygons. Again, like I said, super important that you learn this lesson because this is the foundation for Chapter 7. And I promise you, if you know the formulas, it will not be difficult. So please make sure you guys practice this. All right, parts of polygons. We kind of already know what these things are. Each segment that forms a polygon is a side. We know what a side is. We should already know that. The common endpoint of two sides is a vertex. Again, we know what a vertex is. And the segment that connects any two non-consecutive vertices is called a diagonal. That's definitely probably new, but we know what a diagonal line is. So in the diagram, it's labeled for us. Your sides are in red. Your vertex, I'm just going to go ahead and add extra little dots. This is where the endpoints of two sides connect. And then your diagonals are those lines in green. I'm going to add one more just so you could see where it is. This is also a diagonal, okay? All right, name of polygons. Yes, you have to know the names of the polygons. You will be asked, what is the name of a polygon with blank amount of sides? You will have to write the name. Please do not combine names together. If you are trying to put a decagon with a hexagon and you write hectagon, I'm not going to know what that is, okay? I will most likely mark it wrong, so please make sure you write them how they are spelled. You spell them correctly. The number of sides determines the name of the polygon. We should already know what a triangle is, a shape that has three sides. A number of sides, if it has four sides, it's a quadrilateral, no matter what it is. If it has four sides, it is considered a quadrilateral. 5 sides is a pentagon. If you guys have ever heard about the government building the Pentagon, it is actually in the shape of a pentagon. Hexagon is for 6 sides. 6, you have hex. Okay, they both have an X in it. 7 is a heptagon. That's just one you kind of have to memorize. 8 is an octagon. Think of an octopus. It has 8 tentacles. 9 sides is a nonagon. Think of the number 9. It has N-I-N, but this is N-O-N, and then you have the word agon. 10 and 12, do not get these mixed up. 10 is a decagon. 12, you're adding 2 more letters. Think of it if you want to add 2. Is a dodecagon, okay? Anything after that is an n-gon. So for example, if I were to say, what is the name of a shape that has 20 sides? That is called a 20gon. What is the name of a shape with 13 sides? That is called a 13gon. Do we kind of see the pattern here? Anything after 12 is a that number gone. All right, sum of interior angles. To find the sum of an interior angle measure of a convex polygon, draw all possible diagonals from one vertex of the polygon. So there is, yes, some of you may already know the formula for this. However, if you don't remember the formula, this is the thought process behind it. Drawing all possible diagonals. These right here are considered my diagonals, those little dotted lines. Okay, so we kind of covered that in the first slide. Those are my diagonals. What are they used for? When you are drawing diagonals, it creates a set of triangles. And the sum of the angle measure of all of the triangles equals the sum of the angle measure of the polygon. Okay, I know it's a mouthful. But basically what it says is, if I were to look at these diagrams and I want to figure out what is the measure of all of my angles. So we should know triangle. What is the interior sum? What is the sum of the interior angles of a triangle? Okay. What is all my angles inside of a triangle equal? If I were to add all of them, what do they equal? Good, 180. So if you don't use the formula and you're looking at a quadrilateral, how many triangles do I have in a quadrilateral? I have 2. I'm going to add 180. And 180, and what's 180 plus 180? Good, so this measure of the sum of the interior angles for a quadrilateral is 360. Let me go ahead and look at a pentagon. How many triangles do I have in here? I have 3. 180 plus 180 plus 180 would give me what? 5. Good. 540. So the sum of the interior measure of a pentagon is 540. And then looking at my hexagon, okay, 180 times 4, okay, 720. So the sum of the interior measure of a hexagon is 720. Keep in mind, yes, I'm writing the 180, but that is considered all these angles, okay? All of these angles right here, if I were to add all of these angles, it's going to give me a total of 720 degrees. Doesn't matter the measure of the angles. They could all be different, but they're all going to add to equal 720 degrees. So please make sure you know that. Again, there is a formula. I am going to go over the formula for this. It is easier. Most students just memorize the formula and they plug in what they need and they get their answer. So knowing the formula, it's on here. However, triangle, quadrilateral, pentagon, and hexagon, you should know. Those are the easier ones, okay? Those are definitely the easier ones, so try and memorize those. With practice, they'll come up quickly. But any shape, any number of sides, you're going to subtract it by 2, and then you're going to multiply it times 180. So this is the formula right here that I'm highlighting in yellow. N stands for the number of sides. So if I'm looking at all of these, thinking about the process, if I had, let me grab, we'll do it in this blue. When I'm looking at this, number of sides is 3, okay? I'm doing 3 minus 2, that's going to give me 1. 1 times 180 gives me 180. 4 minus 2 is going to give me 2. 2 times 180 gives me 360. 5, the number of sides is 5 for a pentagon. Minus 2 is going to give me 3. 3 times 180 gives me 540. And hexagon, 6 minus 2 gives me 4. 4 times 180 is 720. Okay, using the formula, I'm just going to give you guys a shape. Let's say we're going to go use 24gon. How many sides are in a 24gon? Good, 24. Okay, number of triangles. I'm going to do 24 minus 2. What's 24 minus 2? Good. So if I were to write it out using my formula, I'm going to have 24 minus 2 times 180. So we said it's 22. And you guys can use a calculator. 22 times 180, it's going to give me a large number. 3,960 is the measure of the sum of all my interior angles, okay? Theorem 7.1 and corollary, polygon interior angles theorem. So again, yes, we will cover proofs. They're going to be short proofs, not too long. This is on the easier side. Polygon interior angles theorem. Okay, the measure of the interior of my angle of a polygon, that's basically what it means. Keep in mind, you have to understand that this says the word sum. The sum of the measure of an interior angle of a convex n-gon, meaning the number of sides, is n minus 2 times 180. Again, that's the formula that you're using for the sum of the measure of the interior angle. Please do not forget this. Corollary to means like in relations to. The sum of the measure of an interior angle of a quadrilateral is 360. And again, that's something that we should memorize. Also, n, if you don't remember, n stands for the number of sides. All right, we covered these two words already, equilateral, equiangular. The only thing that we're learning that is different is regular. If they say a regular polygon, that just means it's both equilateral and equiangular, okay? All right, looking at our first example, it says classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So let's go ahead and look at A. How many sides does A have? 6. So let's say n equals 6. And what's the name of a shape with 6 sides? Good. Are all my angles equal? Are all my sides equal? So this is called a regular hexagon. Okay, all sides are congruent. Also, all angles are congruent. All right, looking at B, how many sides are there in this shape? 4. Okay, so n's gonna equal 4. And what's the name of a shape with 4 sides? Quadrilateral. Are all my angles congruent? Are all my sides congruent? No, so this is just a quadrilateral. And then none are congruent. All right, yes, the pair are congruent. There's a pair of angles, but keep in mind it's all, not a pair, it's all. All right, and then looking at C, how many sides are there in this shape? Good. And it's 12. And what kind of shape is that called? A dodecagon. Decagon is 10. Think if you're adding 2 more, you have to add those 2 letters, the do. Dodecagon. Are all my angles congruent? No. No, my angles are not congruent. Okay. It has to be all, we can think of it as all, yes, all interior angles. They're not all congruent.
So all interior, all exterior?
All interior. Okay. They're not all congruent. Are all my exterior angles congruent? I'm sorry, are all my sides congruent?
Yes.
Yes. Okay. This is just going to be called a dodecagon. I'm not going to call it regular. Okay, this is just a dodecagon. Oops. Yeah, a dodecagon. And then we know that all sides are congruent, so it is equilateral. You want to say equilateral dodecagon, but it's just a dodecagon, okay? My angles are not all the same. All right, looking at theorem 7.2, now this has to do with exterior angles. Okay, exterior angle theorem. The sum of the measure of the exterior angle of a convex polygon. One angle at each vertex is 360. Most important thing you have to know here. For exterior angles, the sum of the measure of any exterior polygon is always 360. Okay? So if you're thinking about exterior, a lot of people had difficulty with this. Exterior are these exterior angles right here. Regardless of the shape, I could have a shape that has 24 sides. What is the sum of the measure of that exterior angles? Meaning adding all my exterior angles, it's going to be 360. What is the sum of my exterior angles of a triangle? It is always going to be 360 no matter what. Now, if it's asking for each angle, it's going to change, and I'm going to give you an example of that. If they were to ask for each exterior angle of a regular pentagon, meaning it's a perfect shaped pentagon, everything is congruent, all my sides and all my angles. They're asking for each angle. They're all going to be the same. So when I'm solving for this, how many sides are there in a pentagon? 5. How many exterior angles am I going to have in a pentagon? Also 5. I'm going to take that 360 and I'm going to divide it by 5 to give me 72 degrees. So that means if it was a regular pentagon, all my exterior angles are going to be 72 degrees. Not my interior angles. This is each exterior angle. Does everybody understand that? There's a difference between exterior and interior. Exterior, the sum is always going to be the same for every polygon, but not each. You have to pay attention to the wording. Okay, you're going to see the difference between sum and each, and it will try and trick you. So definitely pay attention to what it's asking for. All right, now look at it. Again, it's highlighting the word. It says the measure of each interior angle in a regular polygon. It's not asking for the sum, it's asking for each. So for this, the only difference is you are dividing by the number of sides. So giving you an example for this question. Okay, again, it's each. We're going to find the measure of each interior angle of a regular 24gon, since we kind of used that earlier. All right, so I'm going to plug it into my formula. I'm going to have, how many sides does a 24gon have?
24.
Good. I'm going to take 24 minus 2 times 180, and I'm dividing it by 24 because keyword is I want to know each interior angle. I'm going to take that 3,960 and I'm going to divide it by 24. That's going to give me 165. So now I know each angle, not the sum, each angle is 165 degrees. All right, now this question says, find the sum of the interior and exterior angle. Is it asking me for all of them or each of them? It's asking for all of them. Key thing here is to see that word. It's asking me for the sum. So, how many sides are in a heptagon?
27.
Good. N is going to equal 7. So for A, I need to find my interior. Is there a formula for that? Yes, there is a formula for the interior measure of the sum of the angles. Who could tell me what the formula is? What is the formula? Yes. Okay, am I dividing it? No, because it's not asking me for each. Okay, it's just asking me for the sum. So I need to find the total. Okay, so that's why I'm not dividing it. It's just asking me for the sum, meaning I have to add up all the sides. So I'm not dividing it by the number of sides. Who could tell me what is the measure of the sum of an exterior angle? Okay, can anybody tell me what is the measure of the sum of the exterior angle? It's always going to be what? 360, no matter what the shape is, the polygon. All right, so going ahead and solving. Okay, how many sides were in a heptagon? We wrote it, it's 7, so I'm going to solve it as 7 minus 2 times 180. 7 minus 2 is going to give me 5 times 180. That's going to give me 900 degrees. So the measure of the sum of the interior is 900. And what is the measure of the sum of my exterior? Can someone tell me? What is it? 360, good. All right, looking at the next one, 17gon. How many sides are in a 17gon? Good. The number of sides is 17. So solving for my interior, I'm going to solve it as 17 minus 2 times 180. 17 minus 2 is going to give me 15. 15 times 180 is going to give me a large number. It's going to give me 2,700. And then the last part, B, what is the sum of my exterior angles for my 17gon? Good, 360. Okay, do we have any questions on this one? All right. All right, example number 3 says find the number of sides. So that's what I'm trying to find. Find the number of sides of a convex polygon with the sum of the measure of its interior angles equal to 900. So how would I solve this one? How would I set this one up? Yes.
100 divided by 180.
Okay, so we're kind of working backwards, right? We kind of have to work backwards. So if you're thinking about it, setting it up as an equation, I'm trying to find the number of sides. And they're giving me my total of my sum of my interior angles. So I'm going to set it up as n minus 2 times 180 equals 900. So yes, dividing by 180 is something I would do first. Okay, if I divide by 180, I'm going to get n minus 2 equals, what's 900 divided by 180? I'm going to get 5. And then what do I have to figure out? What do I have to do to find the number of sides? Add 2. And n is going to equal 7. So what shape is that? Heptagon. And again, it wanted to find the number of sides, and that was 7. Okay. All right, this last slide, it says find the measure of each, that's the key word here, each interior angle and each exterior angle of the given polygon. I'm going to give you guys a few minutes. Go ahead and try these 3 on your own. I'm going to go ahead and please check your work. So the first one is asking for a regular quadrilateral. How many sides are in a quadrilateral?
4.
Okay, so n is going to equal 4. I'm going to go ahead and plug that into the formula. Keep in mind it's asking for each interior angle. So I'm going to have 4 minus 2 times 180. This is when I am dividing because it wants each. So 4 minus 2 times 180 is going to give me 360. I'm dividing it by 4. I'm going to have 90 degrees for my interior. And then exterior is always going to equal 360, but it wants each, and I'm dividing that by 4. This is also going to give me 90 for my exterior. So 90 for interior and exterior. Looking at my regular octagon, how many sides are in an octagon? Good, n equals 8. So I'm going to have 8 minus 2 times 180. I'm going to go ahead and divide that by 8. 8 minus 2 is going to give me 6. 6 times 180 is going to give me 1,080. Oops. Dividing that by 8, and that's going to give me 135. And that's for my interior. Again, that's each interior. And then I'm going to take 360, divide it by the number of sides, which is 8 again. And that's going to give me 45 degrees for my exterior. And the last one, 15 gon. How many sides are in a 15 gon? 15. Okay, I'm going to again use the same thing because I'm finding each. 15 minus 2 times 180 divided by 15. 15 times 2 minus 180 is going to give me 2,340. Divided by 15, I'm going to get 156 degrees for each interior. And then 360 divided by 15 is going to give me 24 degrees for my exterior.